Hello and welcome to Raw Code Live. Today I am joined by Julius, the co-founder of Prometheus, the founder of PromCon, and newly founder of Prom Labs, the creator of PromLens. Today we're going to be taking an introductory look at Prometheus, and who best to have join me than Julius. Hello, Julius. How are you?
Hi there. How's it going? I love your intro.
Thank you very much. Yeah, I took a lot of inspiration from the IT crowd, if you've seen that before.
Yeah.
Some days I love it, some days I hate it. And what's very consistent now is that I can never start off the introduction properly and always mince my words. So that's now just a feature of the show.
Interesting. When you were speaking, I was just thinking like, oh wow, you have such a nicely collected introduction in your head.
Yeah, it's all a facade. Inside is very different, but I enjoy this. I'm really looking forward to today as we take a kind of look at Prometheus and the problems that it solves, and really give people that Prometheus 101. Like, where do I get started? What does it do, and how can I make it better? So, do you want to just quickly start by telling us what Prometheus is?
Sure. I would say Prometheus is a monitoring system first and foremost, which is based on a time series database that it includes internally. And so it's really, it's a time series based monitoring system for monitoring your IT infrastructure, your services, but also your devices like networking devices, hosts, potentially anything actually that can serialize data in the format that Prometheus expects. So people also monitor their homes with it, like humidity, temperature, or wind farms. What's the current power that they output, anything really that you can press into these kind of time series. But really, it got born initially by myself and Matt Proud at SoundCloud, coming from Google and missing a proper monitoring system for more dynamic environments. So SoundCloud already had a cluster scheduler very early on in 2012. And basically, the key aspect that Prometheus brings to those environments is integrating with service discovery in such a way that Prometheus constantly has an updated view of what things should be where. And it's a pull-based monitoring system. So it actively not only knows which things should be where, but also how to reach them and pull metrics from them over HTTP. So whether that's your application server, your networking device, or anything else, as long as it can serve an HTTP endpoint in the Prometheus metrics format, then Prometheus can collect data from it, store it in a time series database, and then you can make use of that collected data either with dashboarding, showing nice stats, what's going on overall in your system, or actually also basing alerts on that collected data. So you can actually wake people up at night if the website is down, if it's slow, if something else is broken, if your windmill doesn't output power anymore, for example. It comes with a dimensional data model. So there's a metric name and then a set of key value pairs that we call labels, similar to Docker labels or Kubernetes labels, that really give you the different subdimensions of a metric name, like the number of HTTP requests that have been counted on a given server, but then broken up by a method, status code, something else, etc., and the process it came from. So you collect data in that data model, and then it goes together with a query language called PromQL, which we're going to talk more about, I guess, which really makes use of that data model where you can slice and dice your data, as people love saying. So really select exactly the data you want and then aggregate it by any of that dimensionality that you have, but also do more complex operations between whole sets of time series, like binary operations between sets of time series, different transformations, taking rates over counters, filtering, etc., etc. So pretty flexible. And I guess, that's basically it. So you have the data model, you have the pull-based collection, you have the query language. It's pretty efficient in its implementation. I do have to say, though, Prometheus itself, the vanilla Prometheus, is explicitly not a horizontally scalable cloud thing, cluster-based thing, where you just press a button after adding more machines and it just naturally scales up. Prometheus itself is a single host server of which you can run multiple that run in loose federations doing different things. But we explicitly wanted to avoid complex clustering in the system because a lot of things can go wrong in complex clustering. And we basically want Prometheus to be very reliable and simple in its architecture and not get stuck on like some replication or not being able to talk to other cluster members or so. So, if you want high availability in Prometheus, you just run 2 of the same server. They do the same collection, the same alert computation, and then later on you have a component called the alert manager, which actually deduplicates things for you. But they don't actually talk to each other, like the 2 replicas doing the same thing. So I guess that's important to understand. Of course, then you don't really want to overwhelm those 2 identical replicas because then both break. But yeah, so that's kind of the core philosophy, but then there's also re-implementations of Prometheus that take different trade-offs. There's, for example, Cortex, initially started by Weaveworks. Now it's more dominant, I guess, led by Grafana Labs and others, where the trade-off in Cortex is, yeah, we want to have something like Prometheus, but more horizontally scalable. Basically, you just add more machines, press a button, and it still works. But it comes with different trade-offs. It's a way bigger beast to operate.
Awesome. That is a fantastic overview. And I'm looking forward to diving into each of those different components, particularly PromQL. I know from the events that I go to that it can be a little bit difficult for some people to reason around it, and I'm hoping we can just simplify that for them today. There's a question that I've always wanted to ask someone, and I think you're a good person to answer it. And the question relates to why. Why would you write your own database? Like, there must be a certain level of
your own database or a whole own monitoring system.
Well, just the database bit. Like, it's such a difficult and challenging task to go into to write like a TSDB specifically here, rather than using another database.
I mean, like when we started out in 2012, at least, we looked at everything that was out there and were really not happy with any of them in terms of efficiency. So SoundCloud was using Graphite, for example, back then. And yeah, the format at least it was using back then, and also the data model that it was using, so strictly hierarchical and not dimension-based. And the query language that goes along with it were really inflexible and also not efficient in storage, not doing exactly what we wanted, and expecting very regular collection intervals and these things that Prometheus doesn't have. And I could say similar things about almost all of the other areas that ended up being in Prometheus, like the data model, UI, although I mean Prometheus isn't known particularly for a great UI either at the moment. That's part of the reason PromLens is now starting to exist. But when we were looking all these different areas, how alerts tie into things, not really being integrated into the time series system, but usually being a separate system like Nagios and so on, we really wanted to have it work different in all of those aspects. So we were really kind of stuck with building our own. By now, I think there are probably like more alternatives that we maybe could base ourselves on, but PromQL and the way it selects data and does certain things, it also has certain specific both, I think, requirements to the TSDB, but also things it can leave out that more general databases would have to support. Like, for example, if you look at InfluxDB, it supports all kind of data types, et cetera, but that makes it necessarily a way more complex code base versus what we have in Prometheus, which is exactly optimized towards purely numeric time series, exactly this label-based data model and nothing else. So it's really, really well optimized towards that currently. And also what you had previously in more static environments where things weren't changing around so much, you had more long-lived time series where you have your server and you just you monitor it and you see the CPU usage over a year or whatever. And the time series sticks around for a long time though. Now what you have on Kubernetes clusters, especially since the pod name and certain other ephemeral identifiers become part of your time series identity, so as part of a label, the actual time series that exist at any given point of time change all the time. So you need to index them in a way more efficient way that is suited for this more dynamic world. And that was also not really much the case back then with time series databases.
Yeah, well, I mean, I applaud you for doing it. It's one of those things. I think personally, for me, having looked into writing my own database just as a hobby and fun to learn, is one of the most daunting tasks I think I've ever tried to take on. So
yeah,
great.
I mean, I got to say, I mean, we started out with a really inefficient, dumb implementation, and then we went through several revisions, including like a complete re-architecting that works completely different, which is the current storage. And that has become way, way better than the previous iterations at actually, indexing, changing series over time, and so on and so on. And there's now just many companies full-time employing people who are at least part-time, really doing great contributions to making the TSDB like way more memory efficient, faster lookups, and so on and so on. So it's gotten really much better over the last couple of years.
Nice. So we do have our first question, so I'm going to pop that up. But we have a question from Ilya, who is asking, could you have used a NoSQL database? Would that have worked? Or did you really, or do you need to use something that is specific for time series data?
I mean, we started with that with localhost LevelDB, so we didn't want to have anything that's over the network or so. We wanted to, as I said initially, a simple architecture where it's a single process owning everything locally that you can rely on. So if the network breaks down, your monitoring system at least can still work. So a lot of the network-based stuff wasn't really that attractive for us, and we wanted it to be simple to operate, kind of built in to go. So, but yeah, initially we had LevelDB, which is an in-process key value store, and we based our indexes on that. And you can do that, but at least the design that we had initially that I came up with wasn't too great. And it didn't deal well with this changing indexing of series over time. And the current database that Fabian Reinhardt came up with the design is just a complete rewrite from scratch, encoding everything exactly how we need it, after already having many years of experience, what exactly we do need. And I think I'm not able to dive too deeply into the theory of why a particular underlying NoSQL database would work well or not, because I'm not too much of an actual database expert. But yeah, I can only say that the current revision of what we have, which doesn't use one anymore, works way better than what we had.
Yeah, I think the point you made earlier as well is really important here, is that the time to live, or how long we keep around our monitoring data or time series data, is drastically different to maybe like a NoSQL store as well, and that we have to be able to deprecate or kill off that data on a regular interval, and the sharding model can all change. There's a lot of database theory there. So why don't we install Prometheus? Let's show people how it works. So I have the Prometheus.io website here. Now, if we just
figure it out without me telling you anything.
Yeah, sure. I mean, what I'm thinking here is, do we want to jump straight into the 222 RC, or should we play it safe and go with the 221?
I think it shouldn't matter. I think the RC should be pretty fine, but either is totally fine. There's not a lot of changes in the latest version.
All right, so I have a Linux machine here, hopefully with curl. That's a good start. And I will just download Perfect. What did I get wrong there? Let me try again. Oh, there's a redirect. Okay, so that means, what's the flag for the redirect? -L?
Isn't it? Yeah, dash capital L. I think capital L, right?
This isn't supposed to be the difficult bit. Right, there we go.
Nothing would go wrong today. Okay, let me actually check.
WGET doesn't matter. Sorry, Carl. I'm no longer your friend. So we can extract this, and if we go in here, we have our binaries. So right away when we untar this file, we've got Prometheus binary and a prompt tool.
Yeah, actually, that's maybe the first thing that we should do is delete stuff we don't need in here, which is completely optional, like delete license notice console libraries and consoles. And you'll need the -R, for the console stuff. Those are kind of optional things, like the consoles are kind of HTML templates you can serve directly from the Prometheus server. It's a very niche use case. Almost nobody uses it. So this is the remaining 3 files are kind of what you actually need, or actually you only need the Prometheus binary and a configuration file, which is YAML in true cloud manner, which we all love, of course. And the prompt tool is kind of just like a side helper tool. For example, you can use it in CI checks to verify that a configuration file is really valid before you apply it to your Prometheus server or check it into production. And it can do some other linting and helping things, but we don't really need it probably today. So the core thing, you have a Go binary. It will store its data locally in a directory that you tell it to. By default, it will just be ./data. In the current directory. And the configuration file that is there, its main job is to tell Prometheus what endpoints to scrape and how to label the data coming from those endpoints. I mean, there's some other settings as well in the config file. It will tell it, if we do that at some point, how to talk to the alert manager to actually send alert notifications, how to send data to a remote storage system if you want to keep it for later, et cetera, et cetera. But the main thing that we'll be dealing with is basically the scraping, the scrape configs, which you see at the bottom. Maybe just for our demo, let's change the global scrape interval to 5 seconds so we see results and changes coming in faster. So in production, that's a pretty aggressive scrape interval. Typically, you go for maybe 15 seconds to a minute or so. Sometimes people do a second, but that's, you need to have the capacity for that. So this means Prometheus, by default, will go out every 5 seconds to every target, as we call it, these endpoints that it knows about, and collect the current value of each metric from there. In this default configuration here, you see Prometheus only scraping one thing, and that's itself. So Prometheus obviously also exposes metrics about itself on port 1990, where it also runs its web interface. And this setup, as you see it here, is completely useless. It will just monitor itself, but it's a good way to start and see if everything's working.
Awesome. So you're saying we've got a default config for scraping every 5 seconds. We're scraping ourselves, so I could just run
Prometheus. Maybe one additional flag to add that would be nice. What's your current there are certain links in the Prometheus web interface where Prometheus links back to itself, and if you are if this is kind of a virtual machine you're running, and if it thinks it's localhost, but if you click the link and it doesn't really bring you to that Prometheus because it's in a VM or so, then we could tell Prometheus what its externally visible URL is. So for example, from your main host that you run your browser on, it will be reachable under my VM port 1990 or IP something. So these backlinks to itself, we can tell it how to generate them properly. So
this is a bare metal machine on Equinix Metal. It is publicly available, but I'm assuming we're okay because the Prometheus interface is read-only. Is that correct?
Yeah, that's fine. Yeah, unless you enable the admin interface and so on. Yeah. By default, it will be read-only. People can DDoS it, but I hope they won't. So if you do -- and then web.external-URL equals, and then you need to provide the whole URL. So it's like HTTP. And then 1990. should be correct. Yep. And then Prometheus will know to modify the links to itself. Nice. So hopefully we should, we see it starting up. It gives you a bit of a blurb about versions, no errors. Good. Let's maybe switch directly to the new UI. You see the link in the top right. It just looks a bit nicer already. The old UI will go away soon. And if you head to the very top and click on status and targets, we want to be able to see that it actually scrapes the one target it knows about, which is Prometheus itself. So in this case, if you click on that localhost link, yep, now it actually applied this localhost external URL trick. So here we can actually now see the metrics exposed by Prometheus about its own internal operations. It's written in Go, so it'll tell you about like garbage collection, how many Go routines there are, etc., etc. If you scroll further down, there will be more metrics that are prefixed with Prometheus _, and those will be more Prometheus specific, like how many samples have I collected, something about like way more stats about its internal TSDB, how many targets, etc., etc. By the way, there is a Chrome plugin which is really cool. It's called Prometheus Formatter. And if you install it, then you will get this black and white thing in nice colors and with a bit better formatting, these metrics endpoints. I don't know if you want to install that now, but I have it and I always I love it.
Prometheus Chrome extension. Why not?
It's called Prometheus Formatter.
Oh, there we go.
Yeah.
Today I learned.
And it just makes it look a bit nicer. Hopefully it's not virus infected. Ta-da! Oh, that was nice.
Hopefully it's not virus. Thank you for that, as I just installed it on my Chrome browser.
This is not investment advice. Okay, so it looks much more readable already and much more friendly. So what we see here is the data model that I talked about. Conceptually, what happens in this format? So when you go to this endpoint, the process that you get metrics from is basically instructed to serialize its current value of each of the time series that it's currently tracking into the Prometheus format. So you get exactly the current value of each of the time series in that Prometheus is tracking about itself. So it's not about what it has in its TSDB. So there's not really history included here, like what was the value a minute ago or so. Basically, the history is only built by Prometheus itself, coming along every 5 seconds in this case, and storing that history in its time series database. But every time it comes to this page, it only sees what's the current value. So, example, currently the concurrent maximum queries that are allowed is 20, and currently there's 0 ongoing Prometheus engine queries. And like if you reload the page, the next time it might have a value of 1 there or 5 or so, and then Prometheus will just store that current value. Especially those counters that you see, like something seconds count. Yeah, for example, that one. This is a metric that Prometheus will only see go up. So if you refresh this page a couple of times, then you will only see that metric going up. It's like the total number of seconds that the Go runtime has spent doing garbage collection since this process started. So these counters can reset, but only if the process that exposes them and tracks them also actually restarts, because they're only kept in memory. So it's basically one line, one sample, metric name, and then the label values, and then the actual sample value at the very end.
Okay, so let's just break that down, what you just said there. So we call this the metric name?
Yep. So the metric name is kind of the fundamental aspect of the system that you're monitoring. In this case, this is a summary. It's maybe a bit more complex, but let's look at the very simple metric, Go routines. It's the aspect there is, you're measuring the number of Go routines. In this case, there are not even any sub-dimensions, so labels on that metric, but some metrics do. If you scroll a bit further down, maybe we'll find like a good simple one, like further until we see something with more labels that's not a summary or yep. This is good because it's still just a simple counter metric, so always the same metric name. So contract failed connection dialings, but with 4 different subdimensions. So this counts for each of these dialer names and reasons how many of these failures have happened. And then you have the space, and then you have the actual current value of each of these time series. So each time series is identified by the metric name and the unique set of labels following it. So each line is one time series in Prometheus lingo.
Okay, so we got metric names, we got the labels, and we got the value. What is the different metric types that we have within Prometheus then? I see that we've got access to something called a counter. We also had a gauge. There was a summary. I mean, what are these different types of metrics?
Yeah, I actually just gave a talk about that a couple of days or last week ago or so ago. So metric types are, we have 4 of them. Gauge, summary, counter, and histogram. And they're a bit different ways of measuring different aspects of your system. So, for example, a counter is a metric that can only go up because it's used for counting cumulative totals of either requests that you process or total number of seconds spent in a certain CPU mode or something like this. So those are metrics that only go up. And we have a convention that we end them with _total. That's why this metric is named like that, but it's only a convention. But people should follow it. A gauge is a metric that can go naturally up or down. So memory usage, queue length, etc., etc. And then you have histograms and summaries. So a histogram is used for tracking the distribution of a set of values across a number of histogram buckets. So the most common case is request durations that you're measuring in your process as you're handling requests. You might want to record how many of which latency category you have seen. This is a histogram example here. It's not a particularly beautiful one, but it will serve our purpose. So in this case, when you actually track these, when you track things into a histogram in your process that is handling requests, you have a single object where you create a histogram saying, I want to have a histogram, and it will have the following bucket configuration. So latency bucket going from 0 to, in this case, 100 milliseconds, and one from 0 to 200 milliseconds, one from 0 to 400 milliseconds. So it's a cumulative histogram. Every bucket starts at 0 and thus includes the counts of previous buckets, but then has a given upper bound. So you create that object in your client library, and then every time you actually handle a request of a given duration, you just call a method on that histogram, say observe, and you say observe 200 milliseconds, observe 150 milliseconds or so. And internally, the histogram will then increment counters for each of the buckets that are relevant to that event you have just observed. So each of these, so that's one object in the client library as you're tracking things, but then when it gets serialized out in this text format, we have to kind of spread it out into different time series. So the TSDB in Prometheus doesn't really have a clue about what a histogram is. It only knows this schema of like metric name, a bunch of label pairs, and a sample value. So we kind of have to serialize it into that format. So the way we do that is just expose each of those buckets of the histogram as a separate time series with the underscore bucket appended to the original base name of your metric. And then we have the LE label on there. It stands for less than or equal, which means it's like every request gets counted into this bucket that has a latency of less than or equal to 60 seconds. And And yeah, and so basically this histogram gets kind of expanded into this form. You also get two other auxiliary output metrics in the serialization, which is the _sum and _count. This is just the total count of all observations you've made, so total count of all requests, and the total amount of seconds you have spent in handling all those requests. So you could get the average latency by dividing the sum by the count, for example. All right, yeah, so that's a histogram. A summary is, and so by the way, like you typically wouldn't then later on like look at a histogram in its raw form. In PromQL, you would run a function over it called histogram quantile to calculate quantiles from a histogram, or at least approximate them, because it's never going to be perfect. It depends on the resolution of your buckets. But then you can ask questions such as, what's my 90th percentile latency over the entire system or at a given aggregation level? A quantile is something that directly, a summary is a metric type that in the client library already computes these quantiles for you. So directly from the process, as we see here, we get the minimum, the maximum, and the 25th percentile and 50th and so on. The downside is, the upside is you directly get a really well computed quantile, which has little error. And if you compute it using directly the summary type in, for example, the Go client library, you can specify the absolute error margin you want to have in the result. The downside is that you cannot aggregate over quantiles at all. It's just statistically invalid. So if you have 10 processes and they each expose their 90th percentile latency, let's say, you have no idea what the total system's 90 percentile latency is. You cannot average over them. It gives you statistically nonsensical results. But you can do the same with histograms. So, but those, they can be more expensive. If you want to have a good approximation of quantiles from a histogram, you need many fine-grained buckets in exactly the right latency places. So it's a really tricky subject. There's a page in the Prometheus best practices docs that really goes deeper into that comparison if someone wants to look at that more. But most of the time, you want to look at systems in aggregate, so you kind of have to use histograms.
Okay, awesome. That's a really great explanation of those 4 metric types. I'm kind of curious, between the gauge and a counter, are there any optimizations that are made in the database level because you know that a counter can't climb down? Like, why is there that distinction there?
Yeah, so at the database level, the database has no idea. It doesn't know about metric types, period. It does already just, do Gorilla-style XOR float compression on sample values and so on. So if for example, if a sample value stays the same all the time or increases very regularly or so, that already compresses very well. But it has no idea about the type. It's just basically, maybe if we were doing Prometheus completely from the ground up, or if there's a Prometheus 3.0 at some point, we could think about making these metric types more first class, storing them better and more efficiently directly in the database. Even a histogram could be stored way better, right? Instead of like separate time series, it could be one time series with different buckets stored more efficiently. And then also make PromQL itself more aware of that, because currently it's not directly aware of metric types. There are functions that expect input time series to behave like a counter or like a gauge or like a histogram, but the function cannot actually ask the TSDB, like, is this the right metric type?
Okay, I guess that leads us on to a question we have from Ilya in the chat. It just says, is the metric types purely convention, and are there any plans to maybe make them strongly typed in the future? And I think you kind of maybe just answered that a little bit there, if there's a 3.0.
So it is kind of in some places, so there's a whole chain, like instrumentation, collection, processing of the data in the TSDB, and then PromQL. And in some parts of that chain, they're more than a convention. They're an actual code level object And that's the strongest in the instrumentation library, where you really say, I want a new gauge, I want a new summary. And you get different methods depending on which type of metric you created. On a counter, you get an increment method, but no set method. On a gauge, you get a set method, on a etc. And then in the text format, in this exposition format, it's already slightly weaker. It's there in these kind of commented things that get slightly ingested by the Prometheus server, but don't really make it all the way into the TSDB. There's currently, it keeps it. It's kind of, for the longest time, it didn't do anything with it, but then now it stores this help and type information in memory, and you can query it from like for Grafana or Promlens or other UIs that then actually surface this information for the metric names for users. But then in the TSDB, it's completely lost again. And then when you work with stuff in PromQL, you basically have to know what metric is what. And that's why it's important to name your metrics according to conventions. Because, for example, there's the rate function. And the rate function gives you the per second increase of a counter metric. And when it sees a counter going up and up and up, and then down, it assumes, oh, that was a process restart and a reset of the counter, and not like something that could have happened naturally. So it will act as if that reset hadn't happened and kind of neutralizes it away. So if you stick a gauge metric that is like memory usage or so into the rate function, the rate function will think like, whenever the memory usage goes down, oh, that's a counter reset. I act as if it doesn't happen. I will only return you like positive rates. So you'll need to use the deriv function for gauges instead. So yeah, that's important to know.
Awesome. Excellent. So yeah, I think, so I think the next step, and if you agree, let's go down that path. We should add an exporter now. Like, we want something maybe slightly more substantial than the metrics that Prometheus is exposing itself.
Yep. I mean, we could already start querying the metrics about Prometheus itself. We can see like how many samples it is ingesting about itself per second, for example, as a good start. So if you go to, so if you just type, I think head_append, it should fuzzy find the right thing. And then the sample, the second one. So this is a metric name. And in PromQL, if we just give the name of metric name, then it will return all the metrics, all the time series that have that metric name. In this case, it's only one. So the total is a counter metric, _total, which tells us the total number of samples that this process has ingested so far into its TSDB. So you could switch over to the graph tab. And we see it going up over time, right? So it's a counter. So this is completely useless. The one thing about counters is you basically never want to care about the absolute value. You always want to rate them or do something with them. So let's wrap a function around it called the rate function. And yeah, if you go to the very end, you will need to provide the time window to average the rate over. And you do that after the metric name in these angle, what are they called? Square brackets.
That's right.
Yeah. Okay. Exactly like this. So this would give you the per second number of ingested samples, but averaged over 1 minute of ingestion. So we see it currently at 100-something samples per second. So now if we add an actual second target, like the node exporter, we should see this number go up.
Okay, so we want to deploy the node exporter to our machine.
Yes, let's do it.
All right, let's
see. And if we do more complicated
PromQL,
we should probably start using Promlens because it's less of a pain.
Okay, so we have a node exporter. I'm just going to go to releases and grab Linux here. I'll just split this. Is that my IP address? We'll find out. Yes, it is. Okay, excellent. So what do we have? We have license, notice, and then a node export. I'm assuming I just run the binary.
Yep, there's tons of flags, but by default, it will do reasonable things. So the node exporter has nothing to do with Node.js. It's the node in there means like a network node or compute node, so a host. And it exposes all kinds of metrics that you would typically expect about a system: CPU, memory, interrupts, etc., network. You see a lot of collectors listed here in the log already, so you can enable collectors, disable them, enable ones that aren't enabled by default, also configure them, have like include lists, exclude lists of what devices you actually want to include in like network devices, for example, or file systems if you have a lot of these virtual ones that you don't want to have included. But by default, it will give you reasonable information. So the node exporter mostly gets its information from the proc and sys file systems, but it also does a couple of system calls to get information about the machine it's running on.
So just to confirm then, because Prometheus is a pool-based system, our node exporter right now is exposing an HTTP endpoint on port 9100.
Yep.
And currently Prometheus is not actually aware of that, right? We're gonna have to change something.
Yep. And so this is one kind of cool thing. Like when Prometheus isn't actually coming by and scraping, the node exporter is just doing nothing. So it's not collecting any data. It's just since all the operations it does are so cheap, and only take like milliseconds or so, it can do them synchronously. The moment it's scraped, it just like goes to all these proxies files, parses them, translates them to Prometheus metrics, and feeds them back to Prometheus. So yeah, we would now need to go into the Prometheus configuration file and add another scrape configuration. And so just one comment. So currently we have completely static configurations of targets in this config file. Where Prometheus's power becomes way larger is when you have it, for example, in a Kubernetes cluster and you don't configure any target manually. You just say like, talk to the Kubernetes API server, get all pods you know, and then use a certain labeling scheme to identify them and scrape everything. So that's that, and then it keeps itself up to date. But in this case, we're just going to do static targets. Yeah, so if you just copy the first scrape config, and then we can modify it a bit. So let's call it node, yep, and use the node exporter port. Yep.
Easy.
Perfect. And so you can either restart your Prometheus server, which I guess now you already killed it anyway, or you could also send it a hub signal or reload it over the web if you have the admin APIs enabled. But yeah.
Ah, nice.
Reloading or restarting works as well. But it's, of course, not something you would typically want to do in production. You want to like reload the config. Everything in the config is reloadable during runtime.
Yeah. I just didn't want to get into the territory of too many splits on my screen, so I was quite happy.
Yeah.
Kill it and bring it back.
Makes sense.
So,
makes sense.
Let's go to our status targets again.
Yep. Nice. So we have two. We should actually, if you just use the browser back button, we should go get back to the query. And now if we graph that again, yeah, we see a brief outage there because Prometheus was down. And now we see the scrape rate going up.
Yeah, perfect.
Yep. And now if you actually, should we start querying using PromLens right away? It's just so much nicer PromQL interface than the built-in one. I don't want to just like plug my stuff, but
no. Show me the way. Show me the good stuff.
Okay, so the freebie kind of preview version of PromLens that is just hosted directly on promlens.com, you can actually just plug in your that URL as long as your browser can. Oh, see, that's the downside though. You would need to be able to reach it over HTTPS because promlens.com is served over HTTPS and the browser is not allowed to do mixed content AJAX. So that's the downside. You could run it locally though if you do just like a Docker run promlabs/promlens.
Okay, let's do that. So pop open a
with,
new tab. Docker
yeah, with
container
one exposed port, which is 8080.
Is that all I need?
Yeah, I think that's all that you need. Yeah.
Oh, and Docker, of course. Let's check on our little.
And you'll see why I said that. It's going to be much nicer to work with PromQL. So the main reason is actually the text editor, which is currently in PromLens, which is just but the current Docker version doesn't have the very newest stuff yet. Too bad. It's still better than the built-in one. But that text editor will also end up being in Prometheus OSS. Just the rest of the PromLens features will not. So,
yeah, the port goes first. Silly me.
Yeah,
I know better. So you were saying I can just hit localhost on 8080.
Yeah. Yeah, and now if you just paste the server there, and yeah, if you just yep, so that works. Cool. So now we can just type the same metric that we had before, or let's explore node exporter metrics. So if you type node, yep. So the up-to-date version would also show you help strings and type information and all that here. We don't have that yet. Yeah, we could start with the CPU usage, for example, which is the second metric you see here. And if you just press return and you can graph it below, you get a bunch of CPU usage counters. So what you see here is the total number of seconds spent in each CPU mode and in each core and in each process, but we only have one node exporter process, so that's not really useful dimensionality for us. So the main things are the CPU label and the mode label. And so, yeah, we could now, so they are counters, so the absolute value doesn't really help us. So PromLens already suggests you to add the rate function here. So it kind of auto-detects this is probably a counter. And now if you graph it, you will actually see proper CPU usage. Why does it make sense? I have to maybe explain why it makes sense to use the rate function on CPU usage seconds. So what is this? So imagine you only have one core and one mode to make it more simple, right? You have like a CPU usage and it can be between 0 and 1. And imagine your CPU is at 100% usage. Then per second, it would spend 1 second of CPU usage, right? And if it's at 0% use, it would spend 0 seconds for per second in the CPU. So if we take the per second rate over this counter, this is basically giving us the usage in cores per mode and per core. So if you have multiple cores and sum over them, you might actually get, like if you have 4 cores, you might get a number up to 4. You could multiply it then by 100 to get to percentage. And yeah, so you probably want to zoom out a bit in the graph, or zoom in rather, pressing the minus button. This one, because we don't have a lot of data collected yet in the Prometheus server. So just there you see, for example, idle, most of it, like it's almost 100% idle mode. And then you have a tiny bit of usage in the other modes way down there, user and system and so on. And yeah, you have a bunch more metrics about the machine coming from the node exporter.
Okay, so it's this visualization is really great, and I love the fact that it offered to add that rate. I mean, that's instantly very cool.
I mean, I haven't really talked much about PromLens itself yet. I was just like, I can't really use PromLens, PromQL without PromLens anymore. So I'm just like, but so PromLens, to give a bit of a background. So, I mean, I freelanced the last 4 years around Prometheus, just doing consulting, training, custom development for companies. And this year I decided hey, I have a really cool idea for a new PromQL query builder tool that should exist, but I can't really justify just building it completely in my free time and not even, trying to do something commercial out of it. And so I created a company, Prom Labs, and PromLens is kind of my first venture into this whole business of trying commercial software. So it's meant to be run on premise as a Docker container, and you give it a license key, and then it can enable features such as at the top, where you currently have to manually enter your Prometheus server. It can actually talk to Grafana, and it will give you a selector of all the Prometheus data sources in your Grafana installation. It also allows you to create entire shared links that you can send around on Slack and so on to query pages. But the main value of this tool is it's basically a PromQL power tool, I would say. Because the text editor for the PromQL is way greater than what's currently in Prometheus, though I want to open source that, bring that into Prometheus as well. But what it gives you is, once you have more complex queries with different binary operations and filters and so on, in just the text version, it becomes really hard at some point to understand in which different sub-selector and sub-query is it selecting what data and why, what labels are on that sub-selector, et cetera. So what it does is it visualizes the query that you input as a tree here, with every sub-expression becoming its own tree node and telling you what labels are on that tree node and with what cardinalities. So for example, you got 48 different values for the CPU label in this case. Shows you how many results there are. So you can really, really quickly spot in this sub-selector, there's actually 0 results. So the entire expression will never return anything. It will also tell you if there's an error, where exactly that, for example, a group by matching error happens in your tree. I had one consulting session with a client where I had access to their Prometheus server, and then I shared my screen. We went through all of their alerting rules, which are important to work correctly. And half of them were broken. And we could, I just copy and pasted them into PromLens. And in PromLens, we could see pretty much immediately, this sub-selector is not even the right metric name. It always selects 0 series. So this alert will never fire. So it gives you a lot of deeper insights into the structure. Now, the other thing is it also includes a form-based editor. So every node here, you can actually, if you either press E for edit or hover over it, and there's a little icon, you can edit any part of the query using completely form-based editing. So you can say, I want an aggregation, and I want to aggregate over the following labels, et cetera. You could go to snippets, for example, and also say, hey, I want to calculate the quantile from a histogram. Let's maybe just do that. Doop, doop. And there can be more snippets in the future. So it fills out these placeholders, kind of. If you press E again, it will close that. Oops. You can also edit PromQL inline. So if you just double click on a node, or then you can actually edit any part of the tree inline as PromQL, and so on. So it gives you form-based editing, helps you in a lot of ways, gives you little quick actions like add rate, add sum to your expression. Hey, this is a histogram. Do you maybe mean to wrap histogram quantile around it? Basically just helps you really understand and build your PromQL queries way more effectively, and especially avoid completely broken alerts that are way too common.
Okay, so that's really, really useful stuff. Let's tackle one of the questions we have in the chat, and then why don't we contrive a situation then? We'll run some processes. Let's try and spike the CPU use, the disk usage, and see how we can explore those metrics within a node.
Yep.
And give people a good feel for PromQL and PromLens. So the first question we have, another one from Ilya, is asking, can we compare the results from different time periods? Can I compare I'm assuming he's asking, if I view the CPU usage now, can I overlay that with the CPU usage from an hour ago or 10 minutes ago?
Only if you use, not really, not in this tool. It's more for building the query itself and less for like the actual data, like looking at exactly how the data behaved itself, but more about building the correct query, I guess. So you can, so the thing is, the graph tab, there's only one of them on this page currently, and it has one time range. You could theoretically build a PromQL query which selects the current set of time series for something, and then ORs in with a couple of query tricks, like an offsetted version of the same query. But that's a bit cumbersome. Like that's not what you would typically do. Yeah. But what you can do is like really quickly switch what you're looking at. So you can like click with the mouse button on any of these query nodes. Maybe if you go to the hosted PromLens, you will see it better. So promlens.com. If you go to let's say about, and click on that, click on this example page. So really quickly, you can just like click on the mouse on any of these query nodes and then see exactly the shape of the data at any of the nodes. You can also navigate by keyboard with JK, like in Vim, and like this. There's like a bunch more keyboard commands so to help you like navigate around. If you press enter, you go into like editing mode, inline editing of that node, and so on. And you figured it out pretty quickly. So it's kind of like almost like a little gauge or tab that you like stick into the system and see like, okay, what's the value at this sub element here? And whereas like if you do the same thing in the standard just text editor, it gets kind of annoying because you have to like copy and paste different parts of your query into a separate panel, see like what does this evaluate to, and here you just like can immediately see it. Also, like at the very top, if you type a metric name, let's say delete this demo API request duration seconds bucket. No, sorry, like in in there, if you just type bucket, for example. Here you see now you get the type and the help string. So if you just like go up and down with arrows on your keyboard, you see like the actual metadata for each of the metrics being surfaced more nicely.
This looks and feels quite familiar. I mean, is this using Monaco, the VS Code?
It used to, and now I styled CodeMirror next in the same way as it looked before with Monaco. Yeah. Oh, and there's also an explain tab at the very bottom that can actually explain the meaning of any node in sub-expression to you. So if you head over there, and you select a function call, for example, it gives you the documentation for the function. For the aggregation, it explains what it's doing. If you go on the binary operation, which is the root of this entire expression, the slash on job thingy.
Oh, there we go.
Then it even shows you like how it matches up left-hand side, right-hand side. Maybe I'm overwhelming people a bit if they didn't use PromQL before, because we didn't talk really about PromQL much yet. But I guess I went into the mode of, I want to show all the features of PromLens. But I will stop now.
No, I think, being able to visualize the queries, explain them, and have all the documentation in line is a really valuable tool, especially as people are learning how to write their first Prometheus, queries. Like, it can be a little bit overwhelming.
So I want to use it in trainings as well for people to understand like why are the queries working or not working, what exactly does a certain node do, and so on. Yeah.
Okay.
Cool.
So,
okay, let's hand it back to you and stop the commercial section.
No problem. Right. We will. Let's use our Prometheus server with our node exporter. We have the ability to run our PromQL queries and visualize what we have here. So let's try and tackle maybe what would be If someone is just getting started with the Node Exporter and Prometheus, some of the first queries that are popping into my head are, how can I track the CPU usage over time? Or in fact, here's a story. So I used to be an operator or SRE, over the last kind of 5 years, and I always used to get woken up at 3 or 4 a.m. in the morning, and I really, really hate getting woken up at 3 or 4 a.m. in the morning. And one of the most regular culprits was the disk filling up by some bad actor. And I always thought it would be really cool if I could just use some sort of linear prediction to warn me during office hours that the disk was going to fill up in the evening.
Yep.
Now, is that something that we could contrive here, artificially create? Maybe if I run DD and write out a large file on his disk, would we be able to track that usage and see the graph going?
So we can. Prometheus has the function, and by the way, we say also always, like, if you can avoid it, don't alert on these absolute disk usage values, but rather try to predict when will your disk actually be really at 0 free space. And so we have what we typically do or recommend people to do is put the what's the metric called? Like, there's a metric, node file system available disk something, file system available bytes. It's important to use available bytes and not free bytes, because available excludes those blocks reserved for the root user. So you run out of that earlier than just free. And plug that into the predict linear function. So there's a predict underscore linear that works on gauges like this. And you provide it, first of all, on the metric name itself, you provide it with this square bracket selector of how much past data you want to look at for this linear prediction. So it does linear regression over the data points. Typically, you want to look over like multiple hours, right? Let's say sometimes people do 4 hours, because disk usage, often at least, it's not like a very quickly moving thing. So let's say maybe 4 hours or so.
My thoughts were, though, if I'm going to start running DD to fill up 100 gig, it's going to go very quickly. So we maybe want to look at it like seconds, so I can kill it, and then we can just see that.
So this wouldn't actually give you any results, because to do a linear regression, you need at least 2 data points to fall under this window, and we only scrape at a resolution of 5 seconds. So to be really sure, you want to have at least like 15 seconds there, or something a bit larger, like a minute is, let's do a minute. The second thing, the second parameter to this function is, now that we have this linear regression that we're doing over this, we can predict this value into the future. So we can say, based on the current development that we've seen over the last, 1 minute in this case, what will it be in, let's say, 5 minutes? So the thing there at this point in this, it expects a normal expression node and not a duration. So you have to provide it in as a normal number. If we want to say 5 minutes, you could do 5 times 60 or 300. So it expects a number of seconds to predict it into the future. And so now what you get as the output is like the expected disk usage in 5 minutes. And now we could add a filter condition and say, like, only output it to me if it is expected to be less or equal to 0. Or we could just say less than 0. So if we say less than 0, so this filters the set of output time series, but only the ones that are going to be full. And alerts in Prometheus work in that way that the heart of any alerting rule is a PromQL expression, which is expected to output nothing at all if everything is fine, and output 1 or more time series if there is a problem. So then every output time series will be turned into an alert. So for example, if there were two different file systems now for which this condition is true, you would get 2 different alerts, 1 for each, unless you like aggregate over them in PromQL or so. But by default, 2 output time series, 2 alerts. Cool. So yeah, if we now start filling up the disk really quickly, this might at some point start telling you that
you're definitely going to need a new tab now.
And like this is one of the situations where I would then like go into PromLens and see, because the filter, right? You typically don't see anything anymore as the final output of the expression. So then you can still click on the subnode that shows you the current trend of the disk usage and see like, okay, will it even like get close to my filter condition soon, or do I have to change my filter and so on? Okay, yeah, let's trash the disk.
I'm sure there's a way to specify how big I want this to write, and I can't remember what it is.
Yeah, this block size and the count.
Yeah, let's just look it up. So
it's just count and BS, huh?
Is it as simple as this is that's not you. Oh, there we go. So yeah. Okay.
Problem is if it creates sparse files. Yeah, dev random will not create sparse files. That's good, better than dev zero then, yeah. Okay. Otherwise, we won't get the disk usage we're expecting, I guess.
So I should be able to run this. This should create 1001 meg files, right? Yeah. Which is not a lot, but let's
that should be 1 meg basically, right?
Wouldn't the count 1000
create? Oh, the BS is already in kilobytes, right? Or is it in
yes.
bytes? I forgot. Okay.
Kilobytes.
Okay, cool.
I think. All right, so let's just see, right? We have this query here, so we can. I guess the best thing to do is just to duplicate this tab.
Right? BS is in bytes.
Ah, it's in bytes. Okay.
Yeah.
I guess that actually makes sense.
Way more probably, but yeah.
Okay, so
see what you're doing now? You have to like manually edit away parts of the query.
Yeah.
And in PromLens, you just click on that subnode, see like, okay, what's actually returned by this? That's exactly why I don't work in that normal interface anymore.
Okay, so what we're saying is we could actually just use our file system available bytes here, and then what we had was a predict.
Predict linear, yeah.
We had a 1 minute and a 300.
Yep.
So you're saying I can just filter this query to just one section?
Oh, and we had the filter condition as well, the less than 0. Yep. And now you can just click on the nodes and see what each sub-expression actually is doing. Thing is, with a range vector, you cannot graph it because like at any point in time, it would have multiple values. You can table it. you can see like what's the this is the kind of raw disk usage over multiple periods in time, but you can see what the linear prediction of that is, for example.
So I can filter this using the label selector, right? To only get the root disk.
Yes.
And is that just a case of adding?
Yep. Mm-hmm. Yep. Exactly. So now you see, okay, yep, the total query doesn't return anything, but these subqueries do return useful data. Okay.
Okay, so now I do want to start filling up this disk. So let me just confirm what the hell I wrote there. Slash random. That's not the size I was expecting. Or maybe the count isn't doing what I want. Let's just write.
Yeah, I mean, the BS is bytes, so it only would have created like a tiny file. Oh, this is even tinier. Yeah.
Yeah, it was smaller than I expected, So I'm just going to keep writing with DD. So I guess in theory, what I should see now is if you
go to the graph of predict linear, you will see the linear prediction of where this will end up in 5 minutes should go up and up. Like as very soon now, at least.
Yeah, so we're still waiting on that 15-second scrape interval, and we need a couple of values underneath of this.
But it needs 2 samples to actually see the change, and yeah. So if you see at this moment, it looks like it's going down a lot, but it's not. If you look at the y-axis, it's basically staying the same. If you kind of just I guess the only really way to refresh this graph is to either like change one of the settings or select. I should put like a refresh button there directly.
Yeah.
For the sub node, if you wanna graph the predict linear directly. Oh no, actually it should go down because we're predicting the available bytes, not the used bytes. But currently it's still not doing much. So is the actual, like, is it doing much? 0 bytes copied, so it's not doing oh, you want to probably use dev view random, right? Or because it's faster. Random bytes.
Let's just check that's working. Yeah, okay, that's right.
That's working better. Yeah.
So now we have to. We're on a clock now. We have to visualize this before I fill up that disk.
Yeah, before everything crashes and Prometheus runs into problems.
Okay, so predict linear. I'm using my nice autocomplete here. I'm digging it. We want for 1 minute with 300 less than 0. I can click on this. I'm liking this.
Nice.
So now so now we start to write into that disk. We just have to wait for those 2 samples to collect now, which is going to take 10 seconds.
Zoom in a bit, like do over the last 5 minutes or so. Yep.
And I'm just going to split this again so I can actually track the disk usage.
Yeah, that's a good idea. Yeah. And we want to make sure that we're really tracking the right one. So you're writing into root, yeah.
Oh, no, wrong one. There we go. So SDB3, let's just grab. Run that on a watch. Okay, so our disk is filling up. We went from 6%, we're at 7%. It's gone up to 6.34. Okay, right.
Yeah.
So this is gonna. I think it was 100 gigs that said we had 3. Yep. But now that this is slowly filling up, we should see this graph start to take shape, right?
Yeah. So I guess the workaround for not being able to directly refresh this graph for a particular subnode is just select the other subnode and then switch back to predict linear. Or you can just like change the graph setting or something. Yeah. Why is it not going down yet? We should probably try. Can you add another query? Press like
sure.
Add another query and go directly to node file system avail bytes. Oh yeah, we should also add our root mount point filter again, I guess.
Oh yeah, that's a mount point.
Yep. And so that is not doing much yet. It's not really. Is it it's dev VDA. It's not.
Sorry?
Are you sure you're filling up the right machine's root disk? Because it down there in the legend, if you scroll further down, it says device dev VDA, and I think you had SDB something, right?
Oh, am I writing to the wrong disk?
Yeah, I think so.
Or am I on the wrong machine?
Yeah, I think you're.
All right. So can we filter by the series? Like how do I?
Like, are we monitoring the right thing?
CZJ8, CZJ8. Would I get the host name from here? Give me a prompt. Yeah, CZJ8. So we are on the same machine. It's weird that the disk labels are different. But I mean, this is going down, right? This is correct.
Yeah, not really. It's going down like a couple of bytes or something, So if you look at the y-axis, and it's a different device name, so it doesn't look like the right device.
So we went from 6% to 13% usage here. So
Yeah.
if we're seeing a drop in around what, 6 gig?
So I'm a bit confused. Can we make sure we configured Prometheus correctly to scrape from the right host? Oh, wait, at the very top. Oh, I think I know what's going on. Okay. Yeah. 'Cause you reloaded the page. Yeah. So Dun, dun, dun. Okay.
There we go.
Okay, that makes way more sense. I'm like, what's going on? Okay, so yeah, okay. We see the disk usage going down or going
So I
up.
can remove this query, add in my label filter again, where we only want to see the mount point for the root disk. We've got a 1 minute aggregate with a 5 minute prediction.
Yeah. And now if we, so then, okay, so it will still take some time until it thinks we will be. So if you increase the prediction time to, just longer and longer, eventually we will get to the point. Boom. Yeah, now.
Well, it's telling me my disk is going to fill up
in...
Oh, I don't know how to read this.
Well, basically, so what this does is for every point in time in the past 5 minutes, it calculates the value of that PromQL expression for you. You probably only want to look at the current value, like what. So if you go, maybe it's better to look at this in the table view in this case. So which tells like at the current point in time, what is the current prediction based on the last 1 minute, 50,000 seconds into the future.
Right. Okay. And then what it's saying is in 50,000 seconds into the future, I'm actually going to be in negative space on my disk.
Exactly. So we could like fiddle with that number to see when exactly it reaches 0. So maybe 10.
Trial and error.
Yeah. 3,000.
It's fill up now. Is that what it's telling me? Right. No, close.
Yeah. Yeah, good enough. So, like in half an hour or something, if you still had the look only 5 minutes into the future, then it would alert you in, I don't know, half an hour or something.
Yeah, I guess what is important here, like for the scenario that I just randomly threw at you there, is that if we say, in 12 hours, what's that in seconds? 12 hours. I should know that, right? Right, 43,000. Like within the next 12 hours, will my disk be in a negative value? That's what's really important for me there. I know that I should be raising an alert during office hours to say, look, you may want to, and that's only for predictable growth based on the linear prediction algorithm here. It's not going to detect random bursts in disk usage, but still a good alert to have, I would suggest, probably.
Yeah. And maybe just to a bit of an idea of how to use this in a more sophisticated alert, because this one alone is maybe sometimes not enough. You want to combine it with like the trend, but also combine it with the total number of disk space. Like for certain disks have different trends or limits. If you search for Cube-Prometheus, which is a project initially by like in Google, dash Prometheus. Yep, that's fine. And then you press T, and then you press rules, and then you go to the manifest/Prometheus rules YAML, like the fourth one. And I think you search for like node file system avail, like this metric name that we had. So this is one example, for example, like node file system space filling up. You could actually paste that over into Prominence, that expression. To visualize it. The text field at the very top, you could just like paste it in.
Got it.
And so the first thing that does is it calculates the ratio of available bytes to the total size for each of the partitions. It multiplies it by 100 to get 2%, from ratio 2%. Then it filters, so it only gives you those partitions that have less than 40% available space. So this is an alert that would, with just this top stuff, it would alert you for everything that has less than 40% available space. But now it adds an extra condition and says, okay, and for those same label combinations, it has to be true that the linear prediction over the last 6 hours and projected 1 day into the future, this 24 times 60 times 60, has to be also negative, less than 0. Like that's what we did. So if a file system currently has less than 40% free space and in 1 day is projected to have 0, then we want to alert. And there's actually more conditions further down. If you scroll, there's like one more and, which is like, okay, if it's a read-only file system, we want to ignore it. So like in practice, there's a few more conditions you want to add. And it's always tricky also to get this predict linear to work just right for your workload, because like what exact amount of history do you want to look over and how far into the future? You have some workloads that generate like a sawtooth and then they do cleanup and go up again and do a cleanup. And if you look over the wrong, like only over a couple of minutes and project too much far into the future, then you might think like, oh my God, the disk is going to fill up. But actually they do a cleanup way before they actually fill up the disk. So you kind of need to know the workload on your machine and adjust these alerts accordingly. So it is a bit tricky still, but such is life. It's messy.
Exactly. Yeah, I think a lot of this stuff is really just you got to start collecting the data first, and then start to understand how it changes and evolves over time, and write your queries. I mean, I think Prometheus is a really good project. It provides some really sensible defaults, but teams probably want to understand their own infrastructure, their own use cases, and adapt them wherever possible. For sure.
Yeah. Prometheus is great.
Yeah, I mean, we've not even looked at the Prometheus, the Kubernetes integrations for Prometheus yet, and we're just about out of time. So maybe that'll be something for another day where we can, because if we just summarize it, I guess in a few minutes, but where we have been specifying our targets here, and the configuration file itself is not something we would necessarily have to do with Kubernetes. There, is that correct?
Yeah. You basically can have, in the extreme case, you could only have one scrape config where you point it at the API server and map everything over in the correct ways. And then Prometheus will always have an up-to-date view of what is in your cluster. Now, in real use cases, you still have multiple scrape configs for treating certain things a bit differently. And you can do black box probing and like this external probing and so on, and like different things you can do. And I guess like what are other areas we haven't mentioned yet?
We haven't even touched on the alerts.
Yeah, we haven't set up Alert Manager. It's like a component that aggregates the alerts of all your different Prometheus servers, can correlate them, bunch them into one notification instead of like 1,000. Give you nice human readable alert snippets on Slack, PagerDuty, Ops Genie, etc., etc. There's so many, there's like hundreds of open source integrations to get metrics out of all the things you care about. These are called exporters. There are people building and also sometimes offering as SaaS services remote, durable, scalable storages. So if you want to keep your data forever in a durable system, Prometheus can send it there. Yeah, there's so much more.
I think what I'll say to the people that are watching is I will definitely run more sessions on Prometheus. That's a guarantee, especially with Kubernetes as service discovery and looking at how we monitor Kubernetes. I won't make you commit right here and right now that you'll join me in those sessions.
Oh, I'd love to, yeah, for sure.
I was trying to give you a get out of jail free card there, but you threw it away. So yeah, now Julius is just committed to joining me on more exploration of Prometheus within a Kubernetes context. We just have a comment from Hacker saying very interesting and enlightening. Thank you both. So yeah, definitely, Julius, this has been an absolute pleasure. It's been great to see Prometheus and play with the exporter and really get a nice look at PromLens. It looks like a really exciting project, and I'm hoping that there's a lot more to come there as well. So thank you.
Yeah, thank you. That's been fun.
We got one comment popping in at the end there. Let me see if I can read this quickly. For example, I'm beginning to work on a fresh Laravel project. What would be the first metrics you would like to monitor? Give some examples, please. Yeah, okay, we can do this in 3 minutes, right? So Laravel, I don't know if you're familiar with it, Julius, is a PHP framework that delivers web applications. So do you have any opinions? I certainly got a few I can throw out as well on what metrics are important for a web application.
Yeah, for web application in general. So PHP can sometimes be a bit challenging if it's not a long-running server that can actually track metrics over time, like these counters that are supposed to only go up. If you have such a situation, just a general comment, you will immediately need to externalize your events to some system that can aggregate them into counters. For example, send them as statsd style metrics, and then use the statsd gateway that can aggregate them over time and have Prometheus scrape that. Just one thing. Not too familiar with Laravel itself, but generally with web applications, the first things you start tracking are the so-called red metrics, R, E, and D. So R stands for requests, which is basically counting how many requests you've had and of which different types. Like maybe you want to track each method or path or status code a bit separately. So a counter for that. So then later on you can graph with a rate, like how many requests per second are you getting. The second one, E, would be the errors. So if you don't already have it broken up by status code, or if you have errors in your application, you want to count how many of which type are happening. So then you can also alert on that and graph that. And the D stands for durations, basically a distribution of your latencies in your request handling. So you could use a summary for that if you never want to aggregate over dimensions. But typically, probably you would want to use a histogram metric for that to track the request latencies into buckets, and then later on calculate percentiles from that and so on. So those are the first ones, and then it depends very much on the internals of an application, what other stuff is happening in there. Are there queues where you want to expose the length or different other stuff? But yeah, those are the first metrics that are the obvious ones to add.
Yeah, definitely. I mean, I think the ones you've listed there, they're probably libraries. I know that PHP frameworks are very popular. They'll probably handle most of the red metrics for you, handling how many requests come in, the response times, the histograms, and all that. And it's really important, like Julius just said there as well, to understand your own application and then your own instrumentation that actually understands your own domain. So I think there's actually an open telemetry exporter for Prometheus for PHP applications and PHP runtime as well. So there's definitely loads of things you can look at there, Robert. All right, awesome. We have no more questions. I will say thank you again, Julius. It was really insightful and a great learning experience. So thank you for joining me, and I look forward to our next session.
Thank you. That was a lot of fun. Be happy to join again.
All right. You have a nice day. I'll speak to you soon. Thanks.
You too. See you.